So in last class we studied what is minerals and what is ores. And I hope I have given you the tabular column related to important ores of various metals. Around 9 metals I have given the tabular column. Am I right, guys? Everybody? What is their ore and what is the name of the compound and what is the formula? Is it correct, all of you?
Yes, sir.
Yes. So now if you notice it here, and then we studied the types of ores. So we are having 4 types of ores. What is the 4 types of ores we have, everyone? One is oxide ores, second one is carbonate ores, and the third one is respond sulfide ores, and the last one is halide ores. So these are the 4 types of ores we have. And you remember, every mineral is not a ore. Every mineral is not a ore, but every ore is a what? Every ore is a mineral. Understanding? So how we can select a mineral as a ore? So many minerals are present in the earth crust, but every mineral is not turns into a ore. So it has to follow certain properties. So that is what totally the 4 important points has to be considered. So if any kind of mineral is following that 4 features, we is to call that as, what is to call, guys? It is called as a ore. So now in our today's class, we are going to see what is the extraction of metals from their ores and what is the different processes we are using, how we can extract different kind of ores, if it is oxide ore, carbonate ore, halide ore, and other things. Now let us see, before going into the details of these steps which is involving, so we all need to know the meaning of metallurgy, which I already given the definition in the last class. So if you observe, we already studied definition of metallurgy. So can anybody tell me what is the metallurgy means, everyone? So which will discuss about what? All of you?
Extraction of metal.
Yeah. So extract the metal from its ore and refining it to obtain a pure metal. So whatever the steps you are taking, whatever the process you are doing to extract the metal from its ore, and as well as refining it to obtain the pure metal, is only called as metallurgy. That is what you have written in the last class. Am I right, everybody? Mr. Johan, Arane? So now let us see, if you take this metallurgy is a of a particular metal is carried out in various steps, like different metals will follow different kind of things based upon the type of ore. It is oxide ore or carbonate ore or sulfide ore or halide ore. Based upon the ore and as well as nature of the impurities present and based upon the reactivity of the metal. Keep it in mind, the steps which we are following is basically depends on 3 different factors. So based upon that, we will decide which one it is. So what is that? First of all, it is what type of ore it is. And the second one, what is the nature of impurities present? Understanding? Nature of impurities, like either it is a sand or some other kind of impurities, soil or some other thing. Nature of impurities. And then third one, reactivity of the metal. Why reactivity of the metal? Anybody can tell? All of you? Because some metals will react more and some metals will react less. Do you all understand what I'm saying? Some metals will react more and some metals will react less. Is it possible to extract every metal in the same process? That is what is my question. Everybody? Is it possible to extract the every metal from the same process?
No, sir.
No,
sir.
because some are highly reactive and some are least reactive. So based upon the reactivity, we people need to choose which metal we have to extract in what way. Okay, Mr. Aswin Gokul, you forgot to give the naming properly. You are giving different way, new style. Huh? Okay, all of you understand? So now let us see what is the steps we will follow. So the various metallurgical steps for any kind of metal extraction, so we'll follow these things. The first thing is concentration of the ore. So this concentration of the ore means will make it. So based upon the physical appearance, means removal of impurities. That is the first thing you have to remove. Means we will increases the amount of metal in the given ore by removing the impurities. So this is only we also can call it as enrichment of metal. The enrichment name itself we can understand. What do you mean by enrich? Yes, please. Enrichment. Enrichment of ore means in the sense of increasing the concentration. Means try to remove the basic impurities, like not completely it is possible to remove. Like we can say many impurities, if you notice it, otherwise it may create a problem during the metallurgies, like purification process. We have to remove it. That's what the major impurities, so like a sand, and you can notice like soil, clay, stones, like these impurities gone from ore. That is what we used to call as concentration of the ore. Like process of removing the impurities, main impurities, that impurities we used to call something name. Yesterday, day before yesterday we studied. What is that called as? Everybody. That impurities is called as. Respond. Yes, please.
Matrix.
It's also called as gong, or we can say matrix. Okay. So we have to remove that impurity so that the amount of metal in the ore will increases. Okay. So that is what you have to remember. So next step 2. Step 2 you have to do it, that conversion of ore into oxides. This is the most important one. Many years they will ask you about this particular concept. So we will also will study about this one. So more interesting it will be. So conversion of ores into oxides. This is the second step. Whatever the ore it is, we must make it into oxides. Next, third one is reduction process. So we all know that reduction means what? Either addition of hydrogen or removal of oxygen. And then the fourth process is undergoing refining. So this refining is the ultimately the last step of the metals extraction, so that we will obtain the pure metals. So these are the 4 steps which you need to involve for the extraction of metals, like metallurgical steps, which to get the pure metal from the impure ores. That is what you have to remember. Now, let us follow the step by step so that you will understand what it is. So if you notice in our book also, they have given that enrichment of ores, like removing the impurities of the ore prior to the extraction of the metal. If you want to extract the metal, pure metal, the gong from the ore has to be removed. But how we can remove? Is it for every ore same process? No. So it will be depend on what? Physical or chemical properties of the gong. We will choose a different separate techniques are employed. Do you understand what I'm saying? So you can notice it based upon the physical or chemical properties of the, not metal, based upon the physical and chemical properties of the what? Check it here. Gong or matrix. Understanding? We will use different separation techniques are used. So that is what the step 1, enrichment of ores. Do you all understanding, everybody? So I will say the names alone. You can remember what kind of ores, what kind of names we will use it. So all of you observe very carefully. First one. So if you want to separate a sandy and lighter impurities, a sand and lighter impurities, sandy and lighter impurities, like anything clay, soil and all, then we will use a method called as hydraulic washing. Okay, so that's all you remember. What is that and all is not necessary at all for class 10. You just need to remember, for the based upon the physical and chemical properties of the gong, not the metal, we will use that. For sandy and lighter impurities removal, we will use a technique called as we will say hydraulic washing. So basically it will work with gravity principle, specific gravity principle. So more than this, you no need what is what and the process and all. You will study that. So second one, fourth flotation process. This is process number 1. And the second process is FROTH, fourth flotation process. Fourth flotation process. So this one we will use it to concentrate the sulfide ores, particularly applied to concentrate. That is what enrichment of concentrate or enrichment of the sulfide ores alone. Okay, for sulfide ores increasing the concentration, we will use this fourth flotation method. Next, third one, magnetic separation. This is 9th class also you might be studied. Magnetic separation means definitely you can see that we can use this method is applied for what? When the ore is magnetic or the impurities are magnetic. Keep it in mind. The ore contains magnetic nature, understanding, or the impurities are in magnetic nature, we will use this one. Okay, so particularly like a hematite ore of iron, like that's what we can say. Ores which are separated by the technique, like magnetite, hematite, chromite, etc., which are magnetic in nature, we will use this magnetic separation. Either the ore is magnetic or impurities are magnetic. So that is what you have to remember. Okay, this is the third method. And the last method is leaching. So this is the method which we will use basically a chemical. This is actually the chemical separation method. So here what we will do means based upon the difference in chemical properties of the ore and the gum, so we will choose the method. Okay, so that is what we used to call as leaching. So leaching is actually called as chemical separation method. So means based upon the properties of chemical properties of ore and as well as gum, we will choose this process. So for example, if you take bauxite, so bauxite is the ore of what? Anybody can tell? Bauxite is the ore of what? Check your notebook and tell me. Bauxite
Aluminium.
is the ore of what? Aluminium. So bauxite we undergoes leaching technique. So if you take here bauxite, which is the ore of what? Aluminium. So we can separate the impurities by leaching process. So what we will do means, let us study. So bauxite ore is actually reacted with the concentrated NaOH solution. So reaction, tell me. Bauxite ore, formula, tell me bauxite ore. Everybody open your notebook and you have written already. Tell me. Bauxite ore formula, Al2O3 reacting with the sodium hydroxide. So sodium hydroxide and temperature also I am mentioning. So you have to concentrated NaOH solution at 150 degrees Celsius. If you make it, so tell me what is the process what is the products expected? All of you. Sodium, this reaction we have written. Sodium aluminate plus we are going to get water. Sodium aluminate, which is soluble in water. Now this sodium aluminate, if you have taken Al2O2, NaAlO2, so which will react with the water, that is what soluble in water, which will gives us aluminum hydroxide. That is what we can say a white VPT, aluminum hydroxide, plus again we are going to get sodium hydroxide. So this sodium hydroxide, if you heat it, aluminum hydroxide, if you heat it, again we are going to get what? Al2O3 plus H2O. So here if you notice it, sir, here also Al2O3, here also Al2O3. What is the difference, sir? Here we are getting pure alumina. What is the common name? Check it, everybody. Alumina is the common name. So we are going to get a pure alumina. So that is how based upon the chemical properties of chemical properties of metal as well as impurities, gong. The chemical properties of the ore and as well as gong, we'll choose a different techniques. That is why it is called as chemical separation method. Reacting with the chemicals and then they'll separate the impurities very easily. So they change it into a form that they can easily separate it from impurities or gong. So that is what is called as leaching technique. So we will just dissolve in concentrated NaOH solution. We will get sodium aluminate. This sodium aluminate is basically soluble in water. That one will form aluminum hydroxide, okay, which is called as white PPT. One more double displacement reaction, learn it. White PPT plus sodium hydroxide will come. This white PPT, if you heat it further, we'll get again Al2O3 plus H2O. But this Al2O3 is only we used to call as alumina, pure aluminum oxide. This aluminum oxide contains many impurities. Now this one, pure aluminum oxide. So that further we can easily get the aluminum. Am I right or wrong, everybody? Do you understand, all of you? Mitakshri? So that is what it is. So based upon the chemical properties of the ore and as well as gong, we will choose this technique. So one of the example in extraction of leaching by using leaching process is aluminum oxide. So like that, this is the first step in extraction of metals, enrichment of ores. Understanding? So the prior to the extraction of metals, we will use the different processes based upon the physical or chemical properties of the gong and as well as what? Gong and as well as of the ore, both. So based upon the chemical properties of the ore and the gong, we'll choose different techniques. Totally how many techniques? One is hydraulic washing to remove the light and as well as sandy substances. And next one, fourth flotation process, mainly for sulfide ores concentration, magnetic separation like hematite, chromite, understanding, like iron ores and all. And next one is leaching technique based upon the chemical and as well as chemicals properties of ores and as well as gong. We'll use the techniques. Okay. So now this is the step one. I hope everybody understands step one. Next, we are going to see step two. So what is the step two? Everybody see that. What is the step two? Conversion of ores into what? All of you. Conversion of ores into, yes, please, oxide. That is the second step, the most important step which you need to remember. Hari Vignesh, again diluting. Last 3 days I am noticing. No sincerity again. Again late joining. No dedication in our. Like this means no use. So now that is what you have to remember. What is the second step, everybody? Conversion of ores into
oxides.
Understanding? Whatever the ore, you must convert into oxides. So all of you remember, concentrated ores can be converted to metal oxide by using two methods. So let us see that. See, first step, you should make it into concentrated. Do you all understanding, guys? What do you mean by concentrated? We are not going to get pure metal. We are getting the oxides only. Sorry, we are getting the ore only. But the ore will become very pure. Do you all understanding, everyone? That is the meaning of concentration of the ore. I hope everybody clear. Yes, please. All of you.
Yes, sir.
So if you take for example, aluminum oxide, that is what bauxite. Before it is containing many impurities, solid impurities and other chemicals, other XYZ. After process, we are getting again Al2O3. But this Al2O3 is a what? Pure. And this Al2O3 is a what? Impure. It contains many impurities. But here, it contains only aluminum oxide, pure. That is what we used to call as alumina. So every ore has to be converted like this. That is a step one, enrichment of the ore. That is what concentration of the ore we used to call as. Now the second step is conversion of ores into what, guys? Conversion of ores into, yes, please. Step two, write it. Now very important this process. Conversion, many times they will ask you in the exam. Conversion of the ore into oxides. So what is the steps we will follow? So which ores will convert? Concentrated ore or general any ore? Concentrated ore only. Okay, or enriched ore. Concentrated ore can be converted. Can be converted into what? Can be converted to metal oxide. Sir, how? Let us observe all of you. If it is, remember, there is a process called as step 1 process. The process is called as calcination, the most important process. Calcination. So what do you mean by calcination means? Remember, this is the process in which carbonate ores are heated in the absence of air up to a certain temperature, and then they will converting into oxides. Do you all understanding, everybody? So that is the process we used to call as calcination. Calcination means your mind should say immediately, in the absence of what? Absence of air. Absence of air means something. Air is absent, means something is absent. What is that? Anybody? Air is absent, guys. So what is absent? Oxygen. Understanding? In the absence of oxygen, that is what is the process we used to call as calcination. So write it, most important process. A process in which carbonate ores, a process in which, Mr. Hari's understanding, in which a carbonate ore or ores are heated. Carbonate ores are heated in the absence of air. In the absence of air, up to high temperature. Again, we people will repeat this one many times in these concepts. Up high temperature to convert them into what, guys? Carbonates will be converting into what? Yes, please. What is our target? Carbonates will be converting into what? Oxides. Oxides. Why, sir? Why we need to convert it? We cannot extract the metal directly from the carbonate? No. Because carbonates cannot be reduced. Cannot be reduced into metal. This is the most important, because metal directly. So that is the reason we must converting into what? We cannot get the pure metal from the carbonates. So before getting the pure metal, we have to convert into what, guys? Carbonates must we make it into? Yes, please. Oxides. That is what. So now check your tabular column which I have given and tell me what is the examples of carbonate ore. Everybody, fastly. Let me see who will say first. Check the tabular column and tell me what is the one example for carbonate ore, please.
Calamine.
Calamine. Very good. Calamine. What is the name of the calamine? Anyone? Chemical name. Calamine. Hey, tabular column, Sira. Idiot fellow, simply sitting. I know tabular column also many people not written. So what is the calamine name? Check it. Zinc carbonate. So zinc carbonate formula, tell me. What is the zinc carbonate? ZnCO3. So ZnCO3 is the zinc ore. So calamine is the first example. Absence of air. Absence of air. So that what is the oxide? Heat it now. Decomposition reaction. Tell me, chapter 1 you are studying. Still you are not able to say that decomposition reaction. Yes, Mr. Pugal, open your mouth and tell me. ZnCO3 we can make. Like CaCO3, guys. CaCO3, you heat it. What will happen? You will get CaO plus CO2. Am I right or wrong? Calcium carbonate decomposition reaction. Similar way here. Speak. What is happening? So what will happen?
Zinc oxide plus carbon
dioxide will get carbon dioxide.
Zinc oxide plus CO2.
Don't behave like you are something, don't know anything. Everything is similar thing. We all knows that calcium also +2 is the valency. Zinc also +2 is the valency. And 2 plus and zinc is also 2 plus. Oxygen is 2 minus. So product will come same. That's all. Please work. If you are not working, nothing is going to happen. This is an example of this is a decomposition reaction. That's all it is. Next, one more carbonate is there. Check out the list and tell me.
Dolomite.
Dolomite. Dolomite is containing another formula, Hari. So let me take one more thing, lead carbonate. So if you want to extract lead, you can write it. So lead carbonate. So lead carbonate is also in the absence of air. So what will happen? Tell me products. Everybody.
Lead oxide plus
Lead
CO2.
oxide. Lead oxide plus carbon dioxide. Okay. So at least in one class, at least one thing you cannot able to say what is the use of this. That's what. So please write it. So what is calcination? Heating to a high temperature to convert carbonate into oxides in the absence of what? In the absence of
air.
air. That is what we used to call as calcination process. The most important one. Please make it. You all understand, everybody? Girls?
Yes, sir.
Next, second type of one, roasting. So what we will do in roasting, in our house for cooking time and all, the same thing. Roasted peanuts and all, if you will eat correct, the similar thing again here. So, but it is in the presence of oxygen, open air to convert them into oxides. So this process particularly will use, convert the sulfide ores are heated, understand? Sulfide ores are heated in open air to convert them into oxides. That's all it is. So write it. This is the process in which the sulfide ores are heated in open air to convert them into oxides. Remember, sulfur is removed from SO2, or we can say as SO2. So that is what it is. Now, see your tabular column and tell me what is the example of sulfide ore. Check it, everyone. Zinc blend we have written. All of you verify. Zinc two things we have. One is calamine. Next one is lead. Am I right, everybody? Check it, everyone. Yes or no?
Yes, sir.
Yeah. So that is what sulfide was. So write it. What will happen? So zinc sulfide. What is the common name of zinc sulfide? Zinc
Zinc blend.
Yeah, zinc blend. Okay. So zinc blend, if you heat it in the presence of oxygen, open air. So in the presence of oxygen, so undergoes heating and it will come zinc oxide plus sulfur dioxide. I have not balanced it, only oxygen I balance it. I have now balanced the equation remaining. Girls, next equation boys will balance. So lead oxide, sorry, lead sulfide. Lead sulfide, what is the name? Check your tabular column I have given you. Galena reacting with the oxygen will gives us, yes, boys second equation, girls first equation. Make it fast. Let me see who will balance it first. Everybody. Yes. Yes. What balancing this much time? Oh, such a kind of people. It's very, very bad. Balance it. You people cannot balance it. Super. I'm asking balance. Yes.
Sir, 2 ppb.
Yeah.
3O2.
2 ppb plus 3O2.
3O2.
2 PO.
2 PbO.
2 SO2.
Girls, Girls, go and eat and sleep. Okay. Nicely, you people. Have good food. Anything, something you eat and sleep morning itself. 2 ZNO, 3O2 gives you 2 BBO plus 2 SO2. Other boys also. Those are enjoying Mr. Johanna, Nimishe, all relax nicely. Okay. So this is what is the second step in the extraction of metals. What is the first step? Concentration of the ore or enrichment of ore. Second step, what guys? We have to convert that ores into what? Concentrated ore into oxides. So step number 2. Now, there is next step. After converting into oxides, what is the third step? Everybody, see here. Yes,
Reduction.
yes, that is what is called as reduction. So here, reduction, if you notice it, so conversion of oxide into metal, that is only the process called as reduction process. So write it. Conversion of oxide into third step. Conversion of oxide into metal. That is what we used to call as. What is the name of the process? Everybody? We used to call as reduction. Okay. So we all people knows that oxide of a metal can be reduced by simply heating with a carbon or aluminum. So please remember, just by heating with the carbon or aluminum, so the reduction process will be takes place, but the reduction process depends upon the reactivity of the metal. Either it is a more reactive or it is a less reactive. So based upon the reactivity, it will be varies. So that is what you have to remember. So remember, the oxide of metal can be reduced by simply heating with what? Everybody? Yes, please. By reduce it to metal, oxide of metal, reduce it to metal by heating with carbon or aluminum. And it is depends on what? Everybody, reduction process is depends on what? Yes, please. Reduction process depends on the reactivity of the metal. That's all it is. Okay. So now, first one, based upon the reactivity, self-reduction. Self-reduction means automatically by themselves, they will start reducing when they are heating. So that's all it is. So if you take, for example, self-reduction is, we can say like auto reduction. So the oxides of less electropositive elements mainly. So what do you mean by less electropositive elements? Let anybody can tell me. More reactive metals or less reactive metals? Less electropositive elements means. Yes, please. They are more reactive or less reactive? Anybody?
More reactive.
More. Less electropositive means. Please respond. So what is that less electropositive means? I'll give the examples. Mercury, lead, and copper, etc. So tell me now, they are more reactive or less reactive?
Less reactive.
Less reactive.
Less reactive. So these kind of metals, they can be extracted, they can be reduced to free metals by simply heating in the air. That's all it is. Do you understand, everybody? By themselves, they will reduce. No reducing agents like carbon and alumina, these all are not required for these low electropositive elements. Most important one, please remember that. Okay. So it is not required like any reducing agents. So who is the reducing agent here we are using basically? Who is the reducing agent? Carbon or?
Aluminum.
So reducing agents is not required such kind of reduction processes. That is what less electropositive elements which are placed near the bottom of the reactivity series. Near the bottom of the reactivity series means below hydrogen or above hydrogen? Yes, please. Below hydrogen. Check it, everything. Below hydrogen only it is present. Of course, lead is present above hydrogen, but it is also almost less reactive only. So this is what it is. So when concentrated, for example, Hg, mercury. What is the ore of mercury name? Check it, everybody. Ore name of mercury. All of you.
Cinnabar.
Cinnabar. Understanding? What is the name of that? Cinnabar. Understanding? So mercury to mercury. What is the name of that? Sulfide ore. What is the name? It is chemical name. Chemical name of this one.
Mercury 2 sulfide.
Yes. Mercury to sulfide. Am I right, Mithakshri?
Yes, sir.
Yeah, mercury to sulfide. So if you take this mercury to sulfide, when this concentrated HGS is heated in the presence of excess oxygen, then it will automatically converting into mercury to oxide. And further, if it will undergoes continuous the heating, automatically mercury will be extracted. It is like completely, it will be automatically free from all the impurities. But if you remember this, let me write the equations. If you heat it strongly, for them no reducing agents is required. So HGS, so which is in solid state, if I heat it directly, understanding strong heating, so that first it will be converting into oxide ore. Oxide ore. So what is the name of this one? Mercury to oxide. Mercury to oxide, plus we will get sulfur dioxide gas. Now, balance this equation fastly, girls and boys, make it fast. Meeting is going to end, join quickly so that we can continue. Yeah, balance the equation fastly, everybody. Same guys, 2H,
2 H,
yeah,
3
3O2.